In this class, we're going to consider Venn diagrams. Now, Venn diagram is just a useful visual way of representing a set, and more importantly, representing the interaction between multiple sets. Venn diagrams are generally quite straightforward, although very useful in various contexts, but there is a little bit of notation to learn and just a little bit of experience to be gained in working with Venn diagrams so that you can kind of get the most out of them. So let's just start with a simple concept of how we actually represent the Venn diagram. So let's say we've got this set of numbers here, 1, 3, 4, 5. So remember that the curly brackets are the way that we represent set notation. A set is a collection of objects, usually numbers, but not always numbers. But certainly if you're just starting to work with sets, they will generally be number values inside the set, but they can be other things as well, which you might learn about in the future. But let's just imagine for the time being that we're working with sets of numbers. So we've got this set here, 1, 3, 4, and 5, and we want to represent that by a Venn diagram. Well, the way a Venn diagram works is basically just by taking a circle to represent the sort of totality of the set. So we've got the circle here, and then you just take the objects that you've got in your set, the elements of your set, and put them inside the circle. And it doesn't even matter necessarily where you put them, so I could go like 1 there, 4 there, 3 there, and 5 there. There's no strict adherence required to any particular form. As long as you get the objects, the elements of the set inside the circle, then that represents visually that set by a Venn diagram. So this is the Venn diagram. That on its own is not a very profound concept. That is just really to represent, to show how we represent it by a Venn diagram. The bigger benefit is when you start to work with multiple sets and other concepts related to sets. So one of the first ideas that you will meet working with Venn diagrams is the idea of the intersection of two sets and the idea of the complement of a set and the idea of the union of two sets. So we'll start by looking at the union and the intersection, then we'll deal with the complement later on. So let's say you've got these two sets here, A and B, and if you notice that these sets of numbers have got two common elements. So the first set, A, has got the elements 3 and 5, the numbers 3 and 5, and so does the set B. So that means that when you come to draw your Venn diagram, then there should be some way of representing on the Venn diagram the fact that there's this crossover, this intersection as it's called, between these numbers that exist in both sets. And the way that we do this is we just have the circles intersecting. So this, well, first of all, the notation for this is called the intersection, is that we have sort of like an upside down U like this, so the A intersection B like this, and the intersection written in set notation would just be 3, 5. So it's just listing the elements that belong to both sets, the ones that are in the intersection. And when we come to represent this on the Venn diagram, so let's just say we've got our first set here. My circles, by the way, are terrible. I'm not very good at free styling circles. They end up looking like ovals and egg-shaped things. But let's just say that that is approximately a circle. So I'm going to start putting the elements of set A. This is set A here, and I'm going to put the elements here into my circle, and I'm going to put 3 and 5 here on this side, and you'll see why in a moment. And then I'm just going to put the other elements 1, 2, and 7 anywhere. So let's say that we now want to represent the set B also here. Because we know that 3 and 5 belongs also to set B, then we can put the 3 and the 5 such that it's in both the circle for set A and the circle for set B. So when you come to use a Venn diagram to represent the intersection of two sets, this is another terrible circle, by the way, I do apologize. I'm going to have another go at it. So when you're going to do this, then the common elements, the ones that are in the intersection, will exist in this little geometrical space between, or kind of in both of the, oh, this is even worse, in both of the sets. So then I would just fill in the rest of my elements in set B inside the circle, and that basically is how we visually on the Venn diagram represent the intersection. So this part in here, which I guess you could You will sometimes see it shaded in different colors. This part represents the intersection. So a similar but slightly different concept is a union. The union, which is maybe a little bit more, well, I suppose the word intersect, it does mean where two things meet, that these elements are where the two sets meet. The union is where they get, well, joined together. That's, I guess, what union means. So for this one, we use the U the other way around, I guess. This symbol, I don't know if it is a U, but it is handy if it is a U in this case, because you could think of U for union, but basically it's just the symbol the other way around from the intersection. Okay, so this one's the intersection, this one is the union. Notice that in the examples we've got here, set C and set D, there are no common elements, so there would be nothing here in the intersection. So if we drew the Venn diagrams to represent these sets, they would be separate circles. Okay, and in fact, let's go ahead and just do that. So if we go ahead and recognize that there are no common elements here, then that means that the circles representing the Venn diagram cannot intersect. Okay, there's no intersection here. Or you could say that the intersection is the empty set. It's empty, it doesn't have anything in it. If we did this, there would be nothing here. We're doing the union. So what is the union? Well, the union is everything that is in both sets added together. So if we've got set C here, which is 1, 3, 7, and 12, and then we've got set D over here, 2, 11, a 4, and a 13, then these are separate, but their union basically brings them together, and you imagine all of the elements being in one set. And in set notation, we would just literally put them all together. So we'd say, right, this is going to be the superset, I guess, if you like, 1, 3, 7, 12, and also 2, 4, 11, and 13. And you could put those in numerical order as we normally would, but just to show that they're getting all included in the same set like that. So if you wanted to represent this on a Venn diagram, then these are the two original sets. You could then take another circle and just put all of the elements. So 1, 3, and again, it doesn't really matter where you put them, 12, 2, as long as you get them all in there, 11 and 13, and then this here would be the union of C and D, okay? So basic fundamental concepts in Venn diagrams, the union and the intersection, you're going to see that a lot. One more concept we'll look at is the complement. So let's imagine you've got a set, well, let's just take set, let's call this set A here, so we could represent that by set A. If we imagine all of the numbers that are not in A, so that's called the complement, which is written like this, A with a little c, or sometimes I think it can be written A with just a little sort of dash thing there. The complement of a set basically means everything that's not in the set. So when we come to represent these on a Venn diagram, we normally have another structure, usually like a rectangle or a square like this, and we take the set we're interested in, which is A in this case, and we put that inside the square like this. So our set A is 1, 3, 4, and 5. But if you imagine this here, this square, let's imagine we're only dealing here with integer numbers, so like whole numbers. If you imagine this square representing all the whole numbers, which is normally represented by the sort of fancy Z, then inside the square you've got every single integer number, but inside the circle you've got the set A, which is only the integer numbers 1, 3, 4, and 5. Then basically this part here, the part that's inside the rectangle but not inside the circle, so this shaded part here, that is the complement. Okay, so the set itself is just all the elements of the set. The thing that's not in the set, I could actually write it in here, the thing that's not in the set but is in this kind of wider context of, in this case, all of the integer numbers, we can say that that's a complement. So A little c, I'll try writing that the correct way around, so A little c or A with the dash. So some fundamental concepts there for Venn diagrams. Venn diagrams get used in a lot of contexts. They're not only used mathematically, but they're one of those mathematical concepts which are quite important in just sort of everyday life, I guess. You'll see them in various contexts. It's just a way of representing information, kind of like bar charts and graphs and line graphs and all of those things that we use that are mathematical ideas, but we can use them in sort of everyday life and in our sort of ways of representing numbers and ideas about numbers. So the idea of a Venn diagram is just one way of doing that. So learn these key ideas, and that should stand you in good stead for all of the work that you will do with Venn diagrams.